Now, we're all very excited about the future of agentic AI. But what if you need to ask, what if? This has been the promise of digital twins. For SaaS, it's about building simulated environments that enable complex systems to be seen, understood, and optimized. And it's about time that digital twins look like the worlds they simulate. Now, if you haven't picked up a controller and played a game in a while, today's video games are immersive environments that really promote teamwork and collaboration. So I started to think, is there a future we can integrate game engine technology with AI to really make breakthroughs in problem solving? Well, I'm happy to say that SaaS is bringing this vision to life. We are so excited to announce that we are partnering with Epic Games to revolutionize the digital twin experience. The combination of Epic's Unreal Engine, there you go. The combination of Epic's Unreal Engine with our world-class AI allows us to simulate real-world environments, generate synthetic data, and deliver unparalleled insights. And we are already pioneering this initiative with Georgia-Pacific, a leading global leader in paper manufacturing. And what's even more exciting is both companies are here today to talk about this cutting-edge innovation. Get your cameras out. So with that, please welcome to the stage Bill Clifford, Vice President of Unreal Engine at Epic Games, and Roshan Shah, Vice President of AI at Georgia-Pacific. Thank you guys for making the time to be here. This is incredible, and I don't think people are ready to see what they're about to see. It's so awesome. So first, Bill, you've seen a lot of things, and I want to start with you. Give me a little insight into what you think is so unique about what we're doing together here.
Yeah, sure, Brian. As you mentioned, Unreal Engine, kind of the crown jewel of Epic that powers Fortnite, so many other games in the world that third-party developers make, but a lot of people don't know that it's used across a lot of other industries, whether it's fashion, film, animation, live events. I think some of the graphics here earlier were made in Unreal, automotive, and the list goes on. And one of the most common and really valuable use cases that we see is the use of Unreal Engine to simulate really complex real-world scenarios using a digital twin in the virtual environment. And to do that well, you have to have three things. One, awesome graphics that are super photorealistic.
Check.
Two, advanced physics simulation. And three, you have to be able to render a dynamic environment in real time. And of course, all that needs to be rooted in real-world data. We know rendering, we know real-time 3D. You guys know a little something about managing real-world data. And so obviously bringing our engine together with your analytics platform really, we think, can unlock superpowers for customers like Georgia-Pacific.
So, one thing I think we had to do that was really interesting here was we had to build a custom plugin into the Unreal Engine to unlock all the telemetry of the physics and the coordinate systems of all the actors that are happening inside that scene. And then SaaS Viya was able to take that data and really run AI simulations to gain insights. So Roshan, when we kind of approached you about this and what we can do, it was kind of around, okay, what problem can we work on here? So you can give us insights into some of these problems we were looking to address.
Sure. There are actually quite a few that we're thinking it has a large potential impact on. The first we're thinking about is where we can use this capability to optimize our autonomous guided vehicles, so our AGVs. The second one, of course.
AGVs, so they're like robots, like forklifts, but robots, right?
Yeah, pretty much. Yeah.
What could go wrong?
Exactly. Yeah. And of course, the second one being, how could we use this to make our facilities safer? Both of them have, from a cost to, of course, personal safety and large impacts for us.
All right, so given that risk then, what were the key focus areas that you were thinking about here?
Sure. So when we think about the AGVs, the first one is what we call the routing strategies, right? So this is effectively how do these vehicles navigate around. The problem with navigation is, of course, it's dependent on what's kind of going around, so kind of unforeseen situations, if you will. So we've got to take both of those into account. And then the third, perhaps the more intuitive one is, well, how many AGVs do we really need? So solving those three, that's been a big opportunity for us.
Well, by accounts too, this is a pretty complex problem. Can you give us a sense of the scale of this?
Sure. So if you just think about one facility that we're trialing this at, that facility is about 400 meters long, or 4 football fields.
Let me then go over a quick overview of how we've kind of processed data. So first, we use SAS Viya to analyze the current pathing and scheduling of the entire AGV fleet. By the way, that is not trivial in itself. Second, we optimize the combinations of routes and schedules with different constraints based on the missions we want the AGVs to achieve. And then third, we identified a set of potential solutions. And this is the crux of this. But none of those solutions have actually been tested in the real world. And Bill, that's where the game engine really comes in.
Yeah, Brian, so now we can capture all the complexities of the Savannah River Mill in Unreal Engine by creating a digital twin. So instead of having to go out into the real world and build all these potential solutions, we can recreate them in the virtual world through a simulation, and we can design and test and validate and iterate, all using a digital twin. So let's show everyone what we've been working on together. So you can see here, this is the Savannah Mill, rendered beautifully in Unreal Engine, running at a crisp 60 frames per second. The team actually used our photogrammetry software, Reality Capture, to scan the facility, all the objects in this facility, to bring them to life in true-to-life form. You can see the scene is super dynamic, the lighting is dynamic, it's reflecting off of surfaces accurately, shadows are casting accurately, and the team on the back end can use a factory editor to orchestrate simulations.
Yeah, and this is kind of what we have on the screen here, right? So if you notice, those vehicles are moving along. What we need to figure out is, okay, well, do we have them at the right places? Do we need to introduce some new ones? And imagine if you are running the operation, to be able to do that in real time in a graphical manner, that's extraordinarily powerful to be able to manage that, right? You can kind of switch back and forth between this and kind of figuring out what else is the complexity around it, right? And so being able to do that efficiently, that's the big opportunity for, of course. Now, as you go through this, right, the most intuitive problem statement is, okay, well, what happens when you've got too many vehicles, or what happens when you're bunching up, right? So for us to be able to add a new vehicle, kind of just doing point and click, that becomes very powerful. And we can do that, we can even insert them kind of in the middle of the route. Well, the problem may be, and it's not very intuitive, is, you know, it's a bit like driving around at 4 o'clock in Atlanta. You got too much vehicle and you kind of start getting too much traffic, as is kind of evidenced in that video. So then we start thinking about, okay, well, what's the right number of vehicle? Where do we introduce them, and what do we have them do? Well, you have two options. Either you can go and test it all out, or you could simulate that. So in this environment, you know, the capability we built with SAS here, right, is we can go and just say, okay, well, here is my situation. Here's the different vehicles I have. What is the optimal thing I need to do? And we can go and click on and evaluate, and it will, as we're doing here, and it will go figure out how many vehicles there are, what do we need to do, and it actually comes back and says, you know, you need to reduce your vehicles from 50 to 47. And if you did that, you actually reduce your mean time for it to run, or average, by 8%. And that, you know, that translates to real dollars.
So I think, Roshan, I want to take a moment for a second, because this is insane, right? So the work the three of our companies have done together here and the pace of innovation is really amazing. And personally, I believe this is the future of manufacturing. So, you see a lot of opportunities besides just obviously, what we're doing here in manufacturing. Can you share that as well?
This is not an uncommon problem, right? We're seeing massive opportunities in automotive with autonomous driving, robotics, aerospace, and the list goes on. Anywhere where there's embodied AI, we think there's a role for us to play, and we're really excited to explore those opportunities and continue to innovate with SAS, and we're really proud to be a part of the initiative with Georgia Pacific.